If someone asks you in an interview who created Java and why, and you only answer James Gosling, you just gave 10% of the real answer. The real story explains why Java became one of the most important programming language in the world. Today, we rebuild the origin, who created Java, the Green Project story, the engineering problem of the 90s, why C and C++ were limited, why portability becomes revolutionary, how Java solved reliability and security. When I first studied Java during my degree, I memorized Java was created by James Gosling in 1995. That's it. No context, no problems, no engineering reasoning. And later, when topics like JVM, bytecode, portability, garbage collections appeared, they felt random. Now I realize they only make sense when you understand the problems Java was built to solve. So we rebuilt properly. Understanding Java's origin answers many questions like why Java is platform independent, why Java removed pointers, why Java uses garbage collection, why Java emphasizes security, why Java became dominant in enterprise software. Without this foundation, Java looks like a collection of random features. With the foundation, it becomes a designed system. And interviews often test this indirectly. Java was created by James Gosling and a team of engineers at Sun Microsystems in the early 90s. The project started as a part of an internal research initiative called the Green Project. The goal was not originally web development, the goal was to create software that could run reliably on many different electronic devices. Although James Gosling is also known as the creator, Java was developed by a team that included James Gosling, Mike, and Patrick. These engineers were working on a system to support interactive consumer devices. Examples included set-top boxes, smart TVs, embedded systems. But there was a major problem. In the early 90s, computers and the devices had different hardware architecture. Example, Intel processor, Motorola processor, different operating systems. Softwares written for one system usually could not run on another system without modification. This caused a huge challenge. Every new device required rewriting software again and again. This was expensive, slow, and error prone. The team wanted something revolutionary. The engineers were trying to solve three major problems. Problem 1, device fragmentation. Every device had a different operating system and processor. Software portability was extremely difficult. So, the solution idea was to create a language where the same program could run on many machines. Write once, run anywhere. Problem 2, unsafe memory. Languages like C and C++ allowed direct memory access using pointers. While powerful, this caused memory corruption, security vulnerabilities, system crashes. For consumer devices and distributed systems, this was risky. Java solved this by removing pointer manipulation, adding automatic memory management. Problem 3, reliability for networked systems. The earlier internet era was starting. Software needed to be secure, reliable, portable across networks. Java introduced bytecode verification, class loader security model, runtime check. This made Java safer for distributed systems. Initially, the language was called Oak. The name came from an oak tree outside James Gosling's office, but the name Oak was already trademarked, so the team renamed it Java. The language was officially released in 1995. Java was designed around several core principles. Let's understand them. First is platform independence. Programs compile into bytecode. Bytecode runs on the Java virtual machine, that is JVM. The JVM translates bytecode into the machine code. So the same program runs on Windows, Linux, and Mac OS. This solved device fragmentation. Goal 2, security. Java removed dangerous features like pointer arithmetics, direct memory manipulation. It introduced bytecode verification, class loader isolation, and security managers. This was crucial for internet based applications. Goal 3: Automatic memory management. Instead of manually freeing memory like in C and C, Java introduced garbage collections. The JVM automatically removed unused objects. This reduced memory leaks, crashes, and stability issues. Goal 4, that is oriented architecture. Java embraced object oriented design from the beginning. Why? Because software systems requires modularity, reusability, and maintainability. OOPS helped structure complex programs. Let's connect the problems to the architecture. You write Java code, that is hello.java. The compiler converts it into hello.class. This .class file contains bytecode. The JVM reads this bytecode and converts it to machine instructions for specific systems. That's how Java program run on many platforms. Java didn't become popular immediately, but when the internet exploded in mid 90s, Java suddenly became extremely useful. Web applications needed security, network reliability, platform independence. Java was designed exactly for that environment. Java's early design decision still influence modern backend systems. Today, Java powers banking system, e-commerce platforms, distributed microservices. Frameworks like Spring Framework dominate enterprise backend development. Java's reliability and ecosystem make it a long-term technology. Large companies chooses Java because of mature JVM performance, massive ecosystem, strong tooling, stability for long running systems. Organizations using Java heavily included companies supported by Oracle Corporation and platforms developed by the Google. Understanding Java's origin helps when building projects like REST APIs, banking simulation, distributed services, microservice architectures. Because you can explain why Java handles concurrency well, why JVM matters, why enterprise companies trust it. Common interview questions: Who created Java? What was the green project? Why was Java designed? Why were pointers removed? What problem does JVM solve? Strong answer structure is history, then problem, then your technical solution, and then the impact. Common mistakes. Many beginners think Java was built only for websites. Java was built for Android. Java is just another programming language. But in reality, Java was designed to solve hardware compatibility and software reliability problems. When learning Java, always ask two questions. First, why was this feature created? Second, what problem does it solve? This mindset turns you from a coder into an engineer. Now, here's something interesting. If Java solved portability with JVM, then what exactly is inside Java Virtual Machine? That architecture is the next major piece of understanding Java properly. Late summary, basic level, Java was created by James Gosling at Sun Microsystems. Intermediate level, it was designed to solve portability, security, and reliability problems. Advanced level, Java introduced JVM, bytecode, garbage collection, and object oriented design to build scalable distributed softwares. I used to memorize Java facts. Now I'm trying to understand the engineering decisions behind them. That's the difference between learning syntax and rebuilding of fundamentals properly. If you want to truly understand Java, not just write code, stay with this zero gap roadmap. Next, we will break down the JVM architecture, which is the core engine that makes Java platform independent. We are not rushing, we are rebuilding properly.